Today I'm going to teach you guys how to find the test hypothesis in the match pair design data. I'm going to use the find data as an example. A researcher went to select 7 8th graders at Kennedy Middle School and measure how far they could throw a baseball with the dominant right hand and the weaker non-right hand. They thought they could throw equal distances with either hand. The following data was collected. Conduct a hypothesis test to determine whether the mean differences in distances between the children's dominant versus weaker hand is significant. In this case, we can see that the sample is obtained using a simple random sampling. The sample values are matched paired, differences are non-distributed with no outliers, and the sample values are independent. This is a matched pair design data because the variable is measured on the same subject for both the dominant and non-dominant hand. We can say that the dominant hand will represent X, and the weaker hand will represent Y, in which in this case we find that the null hypothesis is equal to 0, and the alternate hypothesis is not equal to 0 due to the fact that Y can have an outcome that is greater than, equal to, or less than the outcome for X. Then what we want to do next is to compute the differences between the dominant and non-dominant hand, which in this case we want to type in your data for dominant hand into L1 and the data for weaker hand into the data for L2. What you want to do next is to find the differences. For example, student 1 can throw at a rate of 30 for the dominant hand and at a rate of 28 for the weaker hand. You want to check 30 minus 28, which will give you 2. You want to type that into L3. Once you have that, you want to do that for the rest of the student. Then you want to hit stat, go to test, go to t-test to get your data. Then make sure your null is 0. Your list on L3, your frequency is always 1. Your alternate hypothesis is not equal to 0. Then you want to hit calculate, which gives you your list of data. Which in this case, your test statistics is 2.18. Your p-value is 0.072. Then you want to see whether you reject or do not reject the norm. First, we can do so by using the classical approach, by comparing the critical value to the test statistics, in which in this case, your alpha is 0.05. You want to use the formula INT, alpha, and sample size minus 1. Since this is a two-tailed test, you want to divide your alpha by 2, which gives you 0.025. And your sample size is 7. You want to subtract by that 1, which gives you 6. When you calculate this, you have a plus minus 2.44 due to the fact that it is a two-tailed test. Then you want to graph it on a Noah's distribution curve. Then you want to see whether you reject the norm or keep the norm. However, your t statistic is 2.18. If it falls within the critical value, you will reject the norm. However, 2.18 falls somewhere right here and does not fall within the critical value, which in this case, you do not reject the norm. Another approach you could use is the p-value approach. If the p-value is less than alpha, you reject the norm. In this case, your p-value is 0.072, in which 0.072 is greater than 0.05, which in this case you do not reject the norm. In which we can conclude that there is no significant evidence at the 5% significant level to show that the children could throw equal distances with either hand. And that is how you solve a test hypothesis using a matched pair design data.